All right. Good morning. So today we're looking at science, and under science we're looking at physics. Now, in physics today we're going to look at mass and weight. Before we go any further, we're supposed to understand what mass is. Okay, so we're saying mass is the quantity, of matter contained, okay, contained in a substance, or we can say object. Okay, so mass is the quantity of matter contained in a substance or in an object. Now, when you look at mass, we're saying that mass is measured. Mass is measured in kilograms, which is kg, or sometimes we can measure it in grams, which is g. And then now, when it comes to the conversion units here, we're saying that 1 kilogram, which is 1 kg, is equivalent to 1,000 grams. So sometimes you can be able to change from kg going into grams or from grams going to kg, but the official units that we use for mass, we use kilograms there. So I mean that we can be able to change if you're given in grams. So for example, let's say you're given 750 grams, you change it into kg. How do you change? So it's very simple. You just say 1 kg is equivalent to 1,000 grams, and then you put under grams, we have 750. So you say 750 grams. But do you know how many kgs are in 750 grams? No, we put x. Then from there we can cross multiply, which means we can have 1,000x is equal to 750. We divide by 1,000, we also divide by 1,000, so that this and this out. So we have x is equal to, in short, 1,000 into 750, it can't put a point, we add a 0. 1,000 into 7,000, it's 7, remainder 500. If we say 1,000 into 500, it cannot add a 0, then we get 5. So what are these units? These units, the x is under kg, so this is under kg. So in 750 grams, there is 0.75 kg. That is how you convert when you are changing from grams into kg. And then mass is measured by what? So mass is measured, okay? Mass is measured by a beam. By a beam balance. So a beam balance is the one which measures, but there are other devices that can measure mass. Those are electronic beam balance, for example, the ones that they use in butcheries, so to say. Then one thing that you should know about mass is that mass is constant, meaning that mass does not change. It is the same no matter where you go. Whether you go to the moon, you come on earth, your mass will always be the same. The mass is always constant. It does not change. So those are the things that you should know about mass. Then coming to weight. So weight is the pull of gravity. Is the pull of gravity acting on an object. So is the pull of gravity exerted on an object, or it is the pull of gravity acting on an object. So meaning that what you check when it comes to that, to say check your weight, what you check there is your mass. Your weight, you are supposed to multiply by the gravity on earth. So weight is the pull of gravity. Weight is measured. This is measured in what? Newtons. It is measured in newtons, which is the capital letter N. Is weight the same or does it change? Weight varies. So weight varies. So weight varies or changes due to places. So when you go to the moon has got less weight. On the moon there is less weight, but on earth there is more weight. That's why you find that gravity on earth, so gravity on earth is which is 10 newtons per kg, while the gravity on the moon is 1.6 newtons per kg. So if you can check, the gravity on earth is more than the gravity on the moon. So how do you calculate weight? So we're saying weight, okay? Weight is equal to mass multiplied by gravity. Sometimes it can be acceleration due to gravity, which means we get W is equal to mg, like that. So this is the formula that we use if we're able to calculate weight there. So sometimes an example, they can give you an example to say, maybe let's say calculate the weight of an object of mass, let's say 70 kg on, okay, the first one we can say on earth, and then the second one B we can say moon. So what will be the weight of this object of mass 70 kg on earth? So weight, according to what we said, weight is equal to mass times what? Gravity. So weight is equal to, what is the mass of that object on earth? The mass is what? 70. Then what is gravity on earth? Gravity on earth, we said it is what? 10 newtons. So we multiply by 10, then we get weight is equal to what? 700 what? Newtons. On the moon, it will be weight is equal to mg, which is weight is equal to, what is the mass of that object when it goes on the moon? We said mass is constant. Mass is the same. No matter where the object goes, mass will always be the same. So the mass of that object on the moon is still 70. Times what? The gravity on the moon is 1.6. So weight is equal to what? If you multiply, do you have a calculator? Okay, can you just try to multiply for me? 70 times 1.6. So which is 112 what? Newtons. So if you can compare the two, we're saying on earth there is more weight than on the moon. That's why on the moon they say there is no gravity on the moon. It's there, but it is the smallest, it is the least, but mass. So here now you can be told to say what is the difference between mass and weight. It's simple. Mass is the quantity of matter in an object, whereas weight is the pull of gravity. Mass is measured in kilograms, weight is measured in newtons. Weight varies, mass is constant, and then apart from that, I think those are the differences. Then weight is measured by a spring balance. So weight is measured by a spring balance. So a spring balance is the one which measures weight, while mass is measured by a beam balance. So those are the differences. The question will come where you'll be told to find the differences between mass and weight. Now, looking at the last part there, we're looking at the stability of an object. So first thing we're supposed to understand what center of mass is. Center of mass. The center of mass is a point at which the whole mass of an object is concentrated on, so to say. That is what you call the center of mass, or sometimes it can be the center of gravity. And then there are equilibriums there. There are three types of equilibrium. There is what you call stable equilibrium. Something which is in equilibrium is something that is stable. it is balanced. If you say equilibrium, it means something which is balanced. So when we say stable equilibrium, is the ability, this is the ability of an object to return or to return to its original position after slightly displaced. So displaced, it means that kutenkana or maybe kuchitenganyako chintu chabe pangono chabe. So the ability of an object to return to its original position after slightly displacement is what we call stable. For example, the way I'm standing, am I stable or unstable? I'm stable, because if somebody pushes me, I'm just going to stagger and then I'll come back again to the original position that I had. It means that I'm stable. Somebody who is stable is somebody who is not able to maybe to change, or who's not able maybe to maybe let's say maybe to change from one thing to another. They're able to still continue with their state of mind, so to say. For example, if we say maybe a duster, if I say this duster, if this duster maybe it is in this manner, it is said to be stable, meaning that I can just displace there, but it will still return back to its original position. A chair, maybe let's say a chair which is in this position, it is balanced. Even a cone, if it is a shape which is in this shape, it is stable, meaning that when I displace it pangono chabe nakatenga nako chabe, it will go pangono, then go back to its original position. That means that this is said to be stable, this is also said to be stable. But something which is the unstable equilibrium is the ability of an object to change the position after slightly displacement. So for example, displacement. For example, something which is unstable is something which is in this manner, or something which is also in this manner. This is said to be unstable. Even the duster, if I had to put the duster in this manner, it means it is unstable. That means that any slight displacement is agwa charapon as a result to change the position. Even me, if I'm standing with one leg, it means that I'm not stable. If somebody just pushes me, I'm going to fall. When I fall, I change the position from the way I was standing. That's why I was saying that stable equilibrium, it is the ability of an object to change the position that it had, to change its original position after slightly displacement. So those are very important. Those are very important because they come. They will draw those two diagrams and then they will come for exam to say maybe which of the following or maybe what type of equilibrium is shown by the following diagram. Very important there. Okay, then there is one which is what we call which is a neutral. Now in neutral, equilibrium is something which is neutral. Is something that does not change when it comes to the center of gravity. It is just the same. The center of gravity does not change. It is just the same. So an example is something which is lying in this state, maybe a ball. These are said to be in neutral equilibrium, meaning that they do not change. They still remain the same. The center of gravity is still the same, whether they are rolled, they are what, and all that. Now, the stability of an object now. Stability of an object. The stability of an object depends on two factors. One is the base area. What does it mean? It means that the wider the base area, the more stable something is. So for example, if I had to draw two objects here, this one and also let me draw another one like this. Between A and B, which one can we say it is stable? The one which is most stable is what? A. Tefio. Why? Because it has got the wide base area. but this one is not stable because it has got an arrow. So as a result, this one cannot change the position. It cannot fall. It cannot change the position easily, but this one can easily change. Why? Because of the base area. So the stability of an object depends on two factors: the base area. The second one is the center of gravity, or sometimes we can say the center of what? Mass. It means that the lower the center, the lower the center of mass to the ground, the lower the center of mass to the ground, the more stable an object is. So for example, again, when you look at the two objects there, and we also look at one which is here. When you look at the center of gravity, it can be here. We said the center of gravity, it is the point at which the whole mass of an object is what? Concentrated. So this one is closer, but when you look at here, the center of gravity can be there. So when we measure the center of gravity, and here, why is it lower to the ground? In A, it is lower than in B, meaning that it is more stable. That's why you find that a long time ago, the buses yakudala, they used to carry luggages on top there. On top here. So it means that these buses, they were unstable. Why? Any slightly most of them, they were what? Falling. Maybe there will be an accident. Why? Because when it is heavier on top, then that means that the center of gravity is what? Raised. An example that I can give is that get a bucket of water, one which is empty, then the other one where there is water. Put the one which is empty at the bottom, then get the one which has got water, put it on top of the one which is empty, and you see what miracles will happen there. Any slightly it will fall like that. Why? Because the center of gravity has been raised, so it has to be heavy at the bottom and than on top. So it means that's why this time around the buses that we have, they have got luggages. They carry luggages underneath at the bottom here. Why? If it is more heavy, it becomes more stable than when it is light. So people will be there, then the luggages will be down here. Why? Because they want to lower the bus. They have to make it heavier and lower so that they can lower the center of gravity. Even these sports cars that move at a very high speed, Formula 1 sports car, they are very small, they are very flat. Why? It means that they move at a very, very, very high speed. As a result, they're making the curves. They're not supposed to top over. As a result, they make them to be stable. Even though sometimes, yes, they will, but it is the rare cases. So this is about the stability of objects there.